Hi everyone and welcome back to the series on TypeScript generics. Today we are going to take a look at generic classes and how they can be implemented. By the way, they are very similar to the way generic functions work, so if you haven't watched that video, I recommend that you go watch it before this one, but in case you've already gone through it, I think generic classes will come easy to you. So let's imagine that we want to create a class for a storage box that is going to contain different items, and we can then add items through a method and we can review all of the items inside. The thing is, we don't really know what the type of the items will be. In some cases, we might create a storage box for strings. In other cases, we might create a storage box for numbers or objects and so on. So how can we implement this? Let's begin by writing a standard class and then we'll extend it into using generics. So I can begin by writing the class keyword, setting the name of the class, for example, storage box. And now I can start writing the properties of the class. Let's say that this class is only going to have one property, which will be the items array. So I can say items, but then what will the type be? I can't really say string array or number array or anything similar for that matter, because I don't really know what the type will be. Well, here's where the generic comes in. So you already know from functions what the syntax is. It's quite similar for classes. You go after the class name, you put the angle brackets, and you write some type variable, whatever you want to call it. You could call it property type, you could call it type, or, as you most often say it, just a letter, mostly T and then U, V, etc. So this will be our type placeholder, and then I'm going to use it everywhere in my class. For example, the items will be an array of this type. We currently don't know what it will be. The thing is, once we create an instance of that class, we'll fill that in. You can imagine generics as parameters for types, right? Just as in a regular function, we have some abstract parameters that we later fill in with specific values. We do the same thing with generics. We start with an abstract type, we don't know what it is, but once we create an instance of the class, or we call the function if we're working with a function, we fill that type in, right? So here we're going to have the items, which are going to be an array of T, whatever that type will be. We can set a constructor. Of course, you can set a default value, right? There are a lot of different options. This is just a demo, so feel free to modify it in any way you would like to. But I'll keep it as simple as possible. So the constructor is going to accept an array for the items. Now, I just wanted to remind you that this name here does not have to match the name of your property, right? This is just like a special function or method that accepts a parameter, and you could call that parameter whatever you want. For example, I could call it initial items, right? And that's still perfectly valid. The only important thing is that inside of the constructor, I say this items, right? Referring to the property equals the initial items. And of course, if you would like to make this example more complex, you could add some sort of validation and so on, but again, I'll keep it simple. So we have the property, we have the constructor. Let's add one or two methods just for fun. So we can create add item, or just add, which is going to accept a new item, which is going to be of type T, right? So all of the items are an array of T's. Therefore, each individual item inside of this array will be of type T. Okay, this method is not going to return anything. It's going to be a void method. So we're just going to access this.items, and we're going to push the new item at the end of the array, right? That's the idea. All right, let's do one more. Let's do getAll, a method that is just going to return all of the items. So it's not going to accept any parameters. We don't need this, but it's going to return an array of items, or we could join them into a string if we wanted to, but for now let's keep it this way, and I'm going to just say return this.items, right? So let's recap what we have so far. We have one property. Again, this is public. I could write the public keyword in front, but I don't need to explicitly state it because it's public by default. So we have the property, we have the constructor that sets the initial value of that property. And we have two methods. The first one is going to accept a new item, and it's going to push it into the array. The other one is just going to return all of the items that we have. And now let's just test the class. So here's the thing. We're going to create a new storage, let's say storage 1. And it will equal new storage box. And here we have two options. The first one is to explicitly state what the type of the items will be. So you see how in the general declaration of the class we have storage box angle brackets T, which is the abstract type, right? So what we can do is once we're creating an instance of that class, we can actually again use the angle brackets and we can pass in the type that we're going to use. Let's say that the first storage will have string items. We can actually say string inside of here. And this is going to work just fine. I can pass in an array of strings now. Let's say that we have, I don't know, a football, we have sneakers, gloves, something like that, maybe for working out. Okay, this is perfectly valid. The thing is, TypeScript infers the types implicitly. So even if I don't write this here, even if I don't explicitly mention that my T in this case will be a string, and therefore everywhere where we have T, in this case we'll have strings, TypeScript will still infer it. So if I remove it, it still knows that these are strings. And if I hover here, I see that we have a storage box of strings. If I try to, I don't know, let's see what we can do. We can add an item, and now it already reminds me that it must be a string, right? It knows it. And I can say, I don't know, just test. I can think of anything else now. We can also, I don't need to log this, by the way. This was a mistake. And we can also log the get all items, right? To see what all of the items are after we have added one. So this works perfectly fine. So TypeScript inferred the type automatically. Now you may wonder, how did it do so? Well, here's the way it works. I'll just quickly hide the methods because I don't need them. When we call the new keyword on storage box, we know that we are basically calling the constructor, right? So here's the constructor. And this array we are passing as our initial items. So if our initial items are an array of T, and in this case we see that the elements are of type string, then TypeScript infers that this is going to be an array of strings, right? So that's how it works. Let me just test it real quick. We can see that after we have added a test item into our storage, we have 4 items in our array, which is expected, right? So this is how this worked for strings. But now we could also create another storage. So we could create storage 2, new storage box. But this time, let's just pass some numbers in the array, right? 45, 30, 23, minus 10, like this. This is also going to work. But this time, the T will be number, right? Because when we use the constructor, we pass an array of numbers. Therefore, it concludes or infers that T will be a number. And if I now try to add a new item, if I say storage 2, add, it automatically reminds me that this must be a number. And I can say 123. And I can also lock storage 2, get all, and I expect to see all 4 items inside of it, right? There we go. It's working just fine. So this is how you can have a 1 parameter type generic class in TypeScript. And in the next video, we're going to take a look at a slightly more complex example where we have 2 generic types inside of our class, inside of our generic class, but this is nothing too new. It's going to be based on the same principle. So I hope this tutorial was helpful, and I'll see you in the next one.